And then, Peyton, what would you do? Excellent, divide by 3. So my 3's cancel. You do not need to flip the sign because you're dividing by a positive. And then it's 5/3 x plus 4. So divide by 3, you end up with 5/3 x plus 4. So slope, y-intercept. TJ, what's the slope in the equation? And then the y-intercept is 4. So when we go to graph this, we begin at B, up 4. Move with the slope. So we're going up 5 and over 3. I can't go any further than that. So I would move down 5 and backwards 3.
I like the ones with the slopes like that. Yeah, you have to graph.
Yeah. Look at that. That's nice. All right. So then the next thing we have to think about, Chase, based off of our inequality sign right here, is it going to be a solid or a dashed line? It says greater than or equal to. If it has the equal to, it's going to be solid. Yeah, so that equal to part means we have a solid line because it's going to be equal to all the points on that line. So if we make a line, yeah, that looks pretty good. And then the last thing, this is where you can make a test point, but I want you to start thinking based off of the direction of the inequality. This is a greater than symbol. When it's greater than, I want the numbers that are bigger. So if I want bigger numbers, would I be shading above the line or would I be shading below the line? Chase, what do you think? Above. So anytime you see greater than or equal to, bigger numbers are above, they're up. So if I go to my line, I'm shading up above that line. So I know the line is diagonal, but I'm still going up above my line because greater than, I want numbers that are bigger. So if it said less than, then I want numbers that are smaller, below the line, underneath the line. Questions? Are there other problems on the worksheet that you wanted to go over? You get stuck on?
That was a great time.
Yeah, please ask. Even those of you at home, please ask if you have any problems that you wanted to go over from this worksheet.
Even if there was one you just didn't get to.
Yeah, you didn't get finished, so you want to make sure you get the extra problem done. Okay. So we are going to go into our notes. And we have one problem to do today. And then, as I said, it's a review. So we're going to be looking at a worksheet, review worksheet.
So we're opening up to page 12. And we got a fishy problem. Like Miss Kane's drawing. So I'll give you a minute to open those up. It's just like chapter 3 with the models we were doing. Nothing too different. All right, Jason, can you read us the problem here? What is bigger, a moonfish or a minnow? Huh? Moonfish? I think so too. I don't know. I'm kind of curious, but it's funny though because the moonfishes cost less than the minnows, even though the moonfish is bigger. So I don't know why they're $3. I would think that the moonfish would cost more than a minnow. The minnows?
Yeah.
Really?
So they can grow to like the size of the fish.
Most fish grow to accommodate to the size of their exposure.
That's cool. Do you ever watch that show Tanked on Discovery? You watch that? It's these guys make custom made fish tanks, usually for like celebrities, and it's awesome.
Is it like on the regular Discovery or is it only on the Discovery Plus channel?
I think it's just regular.
Yeah, I just go. I think.
Yeah. I mean, I think they have it like streaming on some of those. Which reminds me, my Hulu, I got. They had like some Christmas special 2 years ago, where if you would get 2 years worth for $24 total, so it's $2 a month,
Wow.
and that just ran out, and I just got a bill for like $10. I was like, what? So I gotta call them up. So good. Thanks for reminding me.
All those streaming services.
I know. So we have $60 gift certificate, and we want to get two different types of fish, minnows and moonfish. Write a linear inequality to show two variables that represent the numbers of moonfish and minnows. If we're going to write an equation, what's the variables we typically use? Anybody?
What letters do we usually use in an equation?
X and, well, and Y, right? So our X, we're going to say is our moonfish. And then our Y will be your minnows. So next is asking us to graph the inequality and give three possible combinations of moonfish minnows you can buy. So we have a verbal model. We have the moonfish price times the number of moonfish plus the minnow price times the number of moonfish is less than or equal to your gift card. You can't spend more than $60, but you certainly can spend less than it, right? So we're going to go ahead and fill this in with the algebraic model. How much was the moonfish price, Jason? 2. What variable did we use for moonfish? X, good. Plus, how much is the minnow price, Jason? What's the variable for minnows? Good. How much is the gift value? Gift certificate? Good. And that's kind of hard to read, spread it out like that. So I'm just going to rewrite what the algebraic model is. 2x plus 3y is less than or equal to 60, because you could spend up to $60. If we want to graph, what do we solve for, TJ? Yeah. Why? What's the first step? Yeah, subtract 2x. Peyton, what do we get for a final answer here? Close, plus not 30, but got it. Yeah, perfect. So now we want to graph. Where we have X as our number of moonfish on our x-axis and our number of minnows. Notice that we have a y-intercept of 20, right? So one thing we could do is we can make these, what are you thinking?
I think 2 works.
2s? Got it.
I think it'll work.
So we're going to put these in 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, and then 20.
And then if you label the y-axis or the x-axis the same way as the y, then it keeps everything equivalent.
Makes it.
Counting by the same thing.
Alrighty, we put a dot on the y-axis at 20. From here, we're going to go down 2 and over 3. Since, as Ms. Kane said, we have them labeled the same, we're going by 2s, we can just go by 2 lines. It doesn't have to be by $2 or by 2 fish. We can actually just go 2 lines down and then 3 lines over. Does that make sense? And then you repeat the process. And you can only do this because both the X and the Y axis is exactly the same. So you're gonna make your points. And now we're gonna draw a solid or dashed line through this point. Yeah, solid line because we notice it's less than or equal to. So we have the equal to there. So I'm gonna draw my solid line. And Jason, are we gonna shade, it's less than, so we're gonna shade above or below? Yeah, less means below. So what you do is you take a point on the line and then you just shade down. Oops. So you find a point on the line and you just go straight down because you're shading below.
That is some fine shading, Mr. King.
That's why they pay me the big bucks around here. Big bucks. Okay, so now we have a second part of this question. It says, once we graph the inequality, give 3 possible combinations of moonfish and minnows you could buy. A solution is anything in this shaded region. 2 days ago for homework, you had a question that said, pick out 3 solutions to the graph. You guys remember that? No? So all you have to do is you have to just pick out 3 points. So I'll pick out the first one. This one right here. What is that point, Chase? What? Yeah, what's the ordered pair? Switch it around. So we have 4, 8. Good, that's the solution because it's in the shaded region. Hey, give me another point. 14, 4 on 100%. 14, 4. TJ, give me another solution. 10, 6, perfect. And what do these numbers represent? How would you say this if you were going to tell somebody what you could buy? Chase, what does that 4, 8 mean? That you got? Yeah. And you could do you could do 4 moonfish and 8 minnows. That's one possibility. Another one, you could get 10 moonfish and 6 minnows, or you get 14 moonfish and 4 minnows. And any point on here you pick out is going to be a solution to the equation.
Ton of fish for $60.
Yeah.
Maybe we want to get some decorations for the aquarium though. Plants. And swim through Irish maybe.
Mm-hmm. No, I used to have a fish.
That's right. You got in your office.
Oh yeah, he died.
Oh.
My mom, from work, and
Mhm.
great. And most of that time setting up a bunch of fish tanks.
Oh, really?
Yeah, and they're really nice. She made her own little filter pump things. And I don't know if this was after or before, at some point we got, for one of the bigger tanks, we were gonna pick up a tank from an old lady, she was getting rid of it.
Uh-huh.
It was like 500 gallons.
Jeez.
Yeah, we emptied the water, she had like three like giant, like 3 2-foot long plecos.
Mhm.
Which are
Oh.
the ones that stick with suck.
Yeah, I know exactly what those are.
A big catfish too.
Oh.
Catfish died on the ride over, just from stress.
Mm-hmm.
2 of the plecos survived, but recently
That's really cool. Yeah, I always wanted like a nice fish tank in the house. I mean, I just had the little one,
Yeah.
Stephen King. I mean, he was only a beta fish, but he was awesome. He lived for like 3.5 years. I love it.
Aqua World is where Camp Horn meets up with Ralph.
Oh,
Steve,
where
that
the,
place is amazing.
across from the BP.
Yes.
Uh-huh.
Yeah, really neat. Amphibian, reptiles, thank you.
And then you got the Chinese place right next door too.
You could go there then.
Yeah, that's right.
They
Very good.
have that huge koi pond in the back that has really big. You like going there just as a little something to do.
Yeah, I think it's cool. So we're just gonna do practice problems.
Yeah, so you can either use your packet, so if you flip in the packet, the next page is the review. Or this is posted to Google Classroom as a separate assignment. So if you want to do it digitally in Google Classroom, you can. So everybody at home, I don't know.
Yep. At home, can you hear? This is also a separate assignment in Google Classroom. So if you want to go to Google Classroom and upload it, you could just work on it there and then submit that way.
What do you think, Mr. King? Odds or evens? There's a bunch.
Let's do evens.
Yeah, we never get evens under that. So why don't we do the evens? It's 2 pages. So the first page is all the equations, and then the second page has the graphing, I should say inequalities. So why don't you circle the evens? And Mr. King, you can work through maybe a couple of each.
Yeah, I'd
one of
love
each
to.
Group, I guess.
Yeah, I'll go through.
Practice through them.
I'll go through one in each group. So just go ahead through, highlight the evens.
The back as well, yes. So evens of both pages. So the front would be the inequalities, and then flipping over on the back. So evens of both pages, instead of doing all of them. If you want to do all, more power to you, I guess.
Yeah. All right, I'll just start flying through. So the first section, we have 2, 4, 6, 8. Jason, which one would you like me to do with the class?
And then another case is a fraction, Jason, what do you think about
6? Okay, 8 too has the.
that? Oh, 8 has a fraction as well. Let me see how those
Which one, 6 or 8, Jason? Eight, okay. So first thing we're gonna do is we're gonna get our x's together. So we're gonna bring over a 5x. One half minus 5 is gonna give us a negative 4.5. From here, you want to just get x by itself once you combine your x's. Remember, we always want to keep our variables on the left-hand side, whatever variable we're solving for. There's 2 variables, solve for y. Subtract the 5 over. And this is where you're going to have to use a, oops, I forgot my x, didn't I? So now you got to put in your calculator. What do you get when you divide negative 4.5? Well, we're dividing by a negative, so we know that the sign's going to do what? Flip. So it goes from greater than to less than. And then we have a negative, it's going to be a positive. So in your calculator, what do you get? 1 point what? Huh? 1.5. Good. Yeah, you get 1.5. So now we want to graph that. So when we're graphing, if you guys remember, I like to just put whatever that number is that we want to graph. I want to plot that right in the middle. Right here. So I have a 1.5, 1.6, 1.7. Down here you got 1.4, 1.3, 1.2, 1.1. So you can put a couple numbers here. And are we going to keep this circle open or are we going to close it? Remember this. Okay. Yeah, you keep it open. And we're going to shade to on the left-hand side or right-hand side. Yeah, remember here's the arrow. It's less than. If you're going to draw an arrow, it points this way. So we're going to shade to the left. So we haven't done these in a while. You guys going to be okay with 2, 4, and 6? You need to look at another one? Okay, let's go to the next section. It says solve the compound inequality, then graph the solution. Jason, you want to do 10, 12, 14? Okay, 14. So it's compound because there's 2 inequalities in each one. So we have 6x minus 3 is greater than 9, or 4x minus 5 is less than 11. So all we do is we just solve for the variable in each part. So this should not be too hard. Just quick review here. We get 6x is greater than 12. Divide by 6. And we get x is greater than 2. On the other inequality, you add 5. You can just go through these quickly. 4x is less than 16. Divide by 4. And you get x is less than 4. So now we have 2 numbers that we need to put on this number line. So again, I like to pick somewhere close to the middle. I'm going to make, oops. I'm going to make this my 2 here. And I have my 4 here. Then you just fill in a couple other numbers. And then you're going to plot each of those 2 numbers. We have a circle on 2, and we also have a circle on 4. Those are our numbers. Chase, do we keep these circles open or should we close them? Keep them open, yeah, because there's no equal to. All right. So in this case, we're going to have x is greater than 2. This one's a little goofy.
Yeah, it is. I was just looking at that too.
So this one's a little bit goofy. We have x is greater than 2. So we're going to shade on this way. You want me to just keep shade? So it's everything on this one's everything on this side. And then the x is less than 4 is everything on this side. So this whole thing is a goofy one because it ends up being everywhere, right? Yeah.
You should have the whole number line shaded.
Yeah, so the whole thing ends up being like this. Yeah, it's this one's, I'm glad we did together because it's a little goofy.
It really doesn't work out.
Typically you would have one going this way and the other going that way, or shading just in between. So this one was, I'm glad you picked a good one there, Jason. Way to go. If you look up to 12, where it's an and, remember, I'll get you guys started on this. You want to subtract that 3 to both sets of inequalities. And in this one, when we divide by 3, you got to do it to both sets. And here is where you see the two numbers. So if we have a 4 here, 3, 2, 1, 0, -1, -2, -3, -4, -5. Are these going to be open circles or closed circles, Jason? Closed, yeah. And then this is, you see X is between the two numbers. So for this one, you just shade right between them. All right, so you should be able to do number 10. All right, going down next, it says, tell whether the given ordered pair is a solution for -2x plus 3y is greater than 10. So all you have to do here is plug in. TJ, you want me to do 2, 4, 6, 8? Six, got it. Good one to pick. So all we're going to do is we're just going to plug in. So we get -2, and then we're going to plug in the -4 plus 3 times -1/3. And I see if that's greater than 10. Jason, -2 times -4 gives us a? Good. What happens to 3's here, Jason? 3 divided by 3 gives you? 1. Good. So you go -1, and that's greater than 10. Chase, is 7 greater than 10? No. So is the solution? No. That's all. You just plug in. Questions?
You're looking at the same inequality you're using for each one of those. You're just plugging in the different ordered pairs.
Yeah.
The same steps exactly as Mr. King did. Just different numbers to plug in.
Yeah. Here's where you plug in. Questions? So that shouldn't be too hard. And then this is what we've been looking at. We just did. So we just want to graph, but we want to graph. We don't have to use a test point. So Peyton, pick one you want me to do. It's 10, 12, or 14. Got it. Okay, we're going to solve. Add x over. Divide by 3. Now we graph. If we're picking out our slope and our y-intercept, TJ, what's my slope? Good. And then the slope's 3. So then you're going to go graph. Dot on 3, up 1 over 3. Repeat the process to get a couple points. And then you could also go down 1 to the left. Okay. Is it going to be a solid or dotted line, Dan, or Chase? Solid, good, because there's a line underneath that shows equal to, so we're going to draw a solid line. So you draw your solid line through. And then now we're going to either shave above or below. If it's less than, everybody, it's going to be below. Good. So you get a point on the line and you just shade down. Down, below is down. Just like that. And voila. There it is. So the rest of the time is yours to work on.
Yeah, I got that 5 minutes.
Yeah.
Mr. King did close to half of it.
And the hard ones.
Yeah, and the hard ones. Yeah, you did the hard ones. All pages. Don't forget to submit today's homework that was due today. Don't forget to upload that graphing worksheet with the 12 graphs.
Also, look at 10 and 12 when you're here. That'd be 2 good ones to do right now. One's going to be a vertical line, one's going to be a horizontal line. So everybody at home, 10 and 12. One's vertical, one's horizontal. So maybe you could do those right now. If you have questions, we could go over them.